So we have already discussed how to use classes a little bit as a form of storing data and how to use classes to encapsulate data and functions that are related to that data at the same time. We have already provided some examples how it can be used, but there is another very nice feature of classes and object-oriented programming as a whole, and that feature is called inheritance. One thing to notice for this part of the lecture, I am talking primarily about Python 3 syntax, so I'm not going to discuss Python 2 nuances, and if you ever are going to work with Python 2, please pay attention that some syntax parts for declaring classes and using classes together, for example, getting super class of a class, are different in Python 2, and you need to learn the syntax for that from the documentation. Let's have a look at the following example. Here we have declared two classes. One class is called bird, and it has its constructor, and two methods, fly and walk. And then another class, penguin, has bird as argument passed to it. And this syntax means that bird is considered to be a base or superclass of the penguin class. In its body, penguin class declares a new constructor and a new definition for fly method, but have not done anything with walk method. The easiest way to understand inheritance in Python would be to consider that you take the base class, you create an instance of the base class, and then on top of that you add additional bricks from your child class. In this case, we have the base class that's named bird, and all the functions have been defined here. But on top of that, we also have defined these two functions. And defining on top of that, or what is called in programming overriding a function, means that we replace the content of this function and this function with the methods that we have defined for the penguin class. So if we were to create an instance of penguin object and then try to get a value of I am attribute, we will see that it correctly says that I am some penguin and not I am some bird. And the reason for that is that when we called this penguin constructor, we used this penguin constructor, and we never touched the original constructor of the bird class. On the other hand, if we would have done like this and just declared penguin without overriding a constructor, we would have seen that it created an instance with I am attribute set to some bird, because now we have this constructor executing. Other attributes of penguin, in this case where we don't have overridden anything, will look like this. So fly is inherited but also overridden by local class, so we execute this command. On the other hand, walk is inherited but is not overridden, so we keep using the old version of the walk method that have been defined in the bird class. And both of them correctly use self.im that we have set for this penguin instance, even though this method has been declared inside the bird class. So again, in Python, the easiest way to understand how this works is to think that we basically get one base class, and then we glue on top of that some new methods and some new properties, and if we replace something, then the old thing is gone. It's not executed by default unless we do something special. Okay, another example, if we will define another class, and let's call it Emperor Penguin, and it will only override the constructor of the class, but its base class will be already Penguin. If we instantiate an object of that class, we will see that peng2.im is Emperor Penguin, which is correct, and tries to fly but fails is inherited directly from penguin, and walks is inherited from bird. So you can have chain of inheritance that goes for several steps, so you don't have to have just one direct inherited class. Okay, this is very basic explanation, but let's see in practice what this means. One great use and very important use in Python, even in imperative programming, is to define your custom exceptions. For example, now as you can see, we have my exception class that is inherited from exception base class. This is a generic exception, as you remember, and this class does not do anything at all. It literally just is a copy of this exception class but has different name. Now, if we will use raise syntax, this raise statement will basically propagate the exceptions that we have just created here to Python to let it know that exception actually happened, and we didn't just create an exception class and didn't use it for anything. If we do run this code, you can see that my exception happened. So this block has been triggered, and this block is triggered because my exception is set as a requirement. If we were to handle just some generic exception, on the other hand, only generic exception happened. My custom error will be visible, and this block will not trigger. On the contrary, if we didn't have my exception block, running this code will result in a generic exception as well, because my exception is inherited from exception, so it is a subset, and these except clauses, they treat the exceptions based on their subclasses. So if you have exception, this is a subclass that is valid. You cannot raise an exception if it's not inherited from this class. On the other hand, my exception is only a class of its own and has no other subclasses, and exception is not inherited from my exception. This way you can create different exceptions, different types of them, and filter different causes, and even make some groups of exceptions if you want. You can create, for example, my exception group that will mean something, and then you can declare smaller exceptions within that group, inherited from that group. But let's return to our bird classes. One consequence of having methods in inherited classes just replacing the parent methods is the fact that in this case, we will have this constructor for penguin overriding this construction for bird completely, and this means that this property is a bird equals true will never be set. And as you can see, if we try to instantiate peng and try to access is a bird, we will see an error that it does not have an attribute as a bird. In some cases, this would be a desired behavior, but really for constructors, in many cases it is not, because quite often the base class constructor still does some kind of useful initializations that we need. For example, a class inherited from a database connection still wants all the connection functionality to be established before the class can be used. To handle this situation, in Python there is a way to address the functions that were hidden by the overriding function. For example, if we add this line here, this is otherwise completely identical, but if we just add this super round brackets double underscore init round brackets call in front of self.im and we run this code, everything works just as expected. And we actually can access peng.isABird correctly. What does this syntax mean? Super is a special function that returns a reference to the parent class for this particular instance of an object. And in this case, parent class is what we have defined in the first place here. When we will be talking about multiple possible inheritance, that would be important. But for now, we have a simple inheritance, so penguin is a bird, and it is unambiguous which kind of init we want to call. So before running any other code, the Python interpreter will see this line, and it will run this code first, and then it will override self.im penguin. It is possible in Python, a completely valid approach, to run this function after, and the choice whether you want constructor of a parent class called before or after depends on your particular situation. Some classes that would make sense. In some cases you want it to be called first, in other cases you want parent class to be initialized afterwards, even though such situations are much rarer. Finally, you don't have to limit yourself to just calling super on constructor. You can also use super on other methods. For example, in this case, we can use walk and call super version of walk before we try to print something else in the local version that overrides this walk. And as you can see, when we run this, we get some penguin walks but prefers to swim, which is a combination of both events here and here. Okay, now what will happen if we will have a more complicated chain of inheritance? For example, now what will happen if we were to create an instance of class D and call method from D? You can see that now, because we have this very complicated chain of super methods called, we will have the following. So first of all, super method will call super method from B, and super method from B will print out method of the B, which is what we see here. And because this one is not referencing any other super methods, it's fine. It just returns and the operation of d.method continues. On the second step, we are trying to access super method 2, and method 2 doesn't exist in B. And this results in method 2 being resolved from C, because C is the second base class of D, and this is a primary, and this in this case is secondary. And when we call method 2, it gets looked up in B, and it fails to find it there, so it refers to C. Now it calls method 2 of the C, and it's fine. Finally, we do execution of method 2 directly from class A, because we actually want to have this version, particular version, and don't really care what is the superclass of our class. And we can do that using this approach. So we type class name and then method name, and then we manually pass self and the argument. Finally, we just print method of the D. Now this situation is not very frequently met in programming, but in some cases you might want to have this kind of double inheritance. The biggest issue here is that we effectively have the root class A, which is inherited first by B and C independently, and then we have class D, which inherits methods from B and C, and then finally, via each of them, it also inherits methods from A. And sometimes in programming it is a very difficult question, what would be the method that is executed by this super, and in which order they will be looked up, in which classes each methods. In Python, it is quite easy to answer this question, because every class in Python has a special property that is called _MRO, and this property contains the method resolution order, that is the acronym MRO. So the first resolution will happen directly in the class D itself, which is expected, because if we want to call a method that exists in B, then there is no ambiguity anymore. And then it says that it will try to look up things from class B, and then from class C, and finally, only if it doesn't find anything in neither D, B, or C, it will go to A, and then if nothing from there exists, it will refer to object which is a base type, or you can consider that a base class of A, even though it is not explicitly defined here. So as you can see, inheritance can be used to reduce the amount of code you write by grouping all the functions that are generic enough to some parent class, and then have local instances of your implementations for specific cases inherited from that base class, and reuse that code, and reuse those functions, reuse the methods. And when you do this kind of abstraction around your class, you can actually create very sophisticated systems. The only problem is that every time you inherit a class from another one, you actually create a coupling between them. And if then another class would like to change something in the base class that is inherited by two different classes, then you end up with problems such as basically being forced to decouple your code. This is a trade-off that you have to define on architectural level. It is often difficult to tell ahead of time which would be the best solution. There are many different approaches to structuring of your data within classes and between classes, and we are going to bypass this all. And if you are interested in this, you will have to look for specific literature on principles of object-oriented programming outside of the Python in general terms, rather than for a specific language. But here are the tools that you can use within the Python to implement object-oriented programming. And if you are going to see some kind of object, and in Python pretty much everything is an object, you now know how to define methods, how you can define your own classes, how you can group things, how you can create inheritance, and how to look up the most critical information, namely the method resolution order, which is going to help you a lot if you are going to create a complex structure of class inheritance.